along with business analyst, the data architect will be doing it. Some cases we don't have that luxury. Okay, you have only the offshore. You have 4 members or 5 members are there. On site, you don't have any people from our India side, working out of the customer premises. In that kind of situation, the Americans, right? They will walk you through the business domain, everything, and then they will explain the table. What are the tables that are required, all the relationship, everything. Maybe they will tell you, but you need to create it everything. End of the day, okay. Look here, if I go to the Power Pivot here, this is your model view. It is also called as a Power Pivot. Okay, don't 1 second. Let me record it. Okay, recording is going on. Good. They will ask you to do the design, everything. Okay, and here sometimes, right, but most of the cases, if you are going to work in a existing project, which means already they have a data warehouse. They have a data warehouse, customer side. Look here, I just write it here. So in most of the cases, this is what is happening. So they have something called data warehouse database. Okay, the database is a kind of a data warehouse. Okay, it is a concept. Data warehouse is a concept. End of the day, it's a database. Okay, so your data warehouse is data warehouse related tables and schemas they already created in a database. Okay, this is lying on your SQL server. Okay, this server, so this database they created in a SQL server. And here, right now you are going to, let's say this is your source system. Source system, in the case of e-commerce, all the tables and all the orders customized by customers will get stored here. This is the first place where the data will get loaded. The everyday transactions, every minute, every second, the transactions will get loaded into these source system tables. We have another database, database 1, database 2. In the database 1, that is meant for the applications, the customers, the end customers. They are the one ordering the products across the globe. Let's think that way, okay? So the data will get stored here. So this is for, this database is meant for catering to the end user's need. Supposing you wanted to order some products, then application should be there. Whatever the orders that you raised it, that one should get stored here. Whenever you wanted to click on the order in your app, it should show all the current order, the order status, and when you raise the order, and the order status it will show, and also the previous orders also display. So all these data are available in the source system database 1. This is called OLTP. Please remember this. Online transaction processing. This is meant for transactional purpose. Every day, every minute, whatever the orders raised by customers, it will get stored here. But again, it will not get stored everything in a single table. It will get stored in different table. Logically, the customer related information, the customer table will get stored, and then whatever the order that they raised it, right, that one will get stored in the order transaction table. And then the customer address will get stored in another table. And then you have something called the product table, and then master table. They call it a master table here. In the source system, in the source system, they have something called master tables, master and detail, or transaction tables. The master table 1 and 2. So in master table, you have different, multiple tables will be there, like a product table, address table, customer table, and then store table. Likewise, multiple tables will be there. Okay, order transaction, order header, and you have something like likewise the product category table. Likewise, different tables will be there. It's all master table. Why it is called master table? Because those tables will have unique instance of each record. For example, in the customer table, the customer ID will not get stored more than once. Each customer detail will get stored only once, and each product detail will get stored in only once in product table. Hence, it is called master table. It is also called as a lookup table, master table, or lookup table. Okay. And the detailed table is nothing but your the order transaction tables. In the detail table, order detail or order transaction table, in that kind of situation, they they store day-to-day orders, everything, everything will be stored in that table. That table will also contain huge volume of the data. So this is meant for the customers, to cater to the customer's needs. This database will be dedicated. It is it's a live database. It will be accessed anytime by customers across the globe. You just think that way. It is a 24/7. Okay, what about this data warehouse? This is meant for internal stakeholders in your company, the CEO level and all the C-level executives, right from the operation managers to the C-level executives. They want to do analytics. They wanted to keep a track on or keep a tab on what is happening in my business on a day-to-day basis, weekly basis, and monthly basis. Every week, this top level executives, they want to see what is happening currently at a high level. Operation level managers, they want to track on a daily basis. Unless they track on a daily basis, they will not be able to manage the day-to-day show. How many number of items are there? How many units are available in stock? How many units we need to order it from our vendors? All the details will be stored in. Then they want to see, the details are stored in a data warehouse. They want to do analytics. Okay, which products are top selling products, top moving products, slow moving products, all the analytics that will be done by your store manager or sales manager, marketing manager, they will do analytics. Likewise, for each department, they have different schemas. Let's say this is your finance manager, he wants to see his own reports. And here the sales manager wants to see his own reports, and then marketing manager wants to see his own reports. Okay, and even let's say if it is a production-based company or purchase department, they have a separate schema. These schemas are called as a subject area. In data warehouse, we call this as a subject area. Each subject area, this is sales subject area, marketing subject area, financing subject area, and then you have purchase subject area, and then you have costing. You have something called costings, category planning is another, the schema. Likewise, different subject areas will be there. The schema is called as subject areas. So this one, as part of this, for example, if it is going to be a, sales related subject area, what you are seeing could be this, the tables. You have category table and date dimension. In the case of analytics, see, the data values is meant for analytics. This is for the transactions, day-to-day transactions. Okay. They don't want to do everything in a single database. If they want to do analytics, as well as if this database has to cater to all the end users, it will literally get slowed down. Because in the data warehouse, you do a lot of aggregation. You summarize the data, sum of sales by quarter, by month, by year. Okay, you do aggregation. Here you have huge, humongous amount of data will be there. Okay, so let's say if you work for a very small company, you don't have to worry. Okay, but you will not be paid high also, right? If the volume of the data are very high, and if the challenges are more with respect to data and creating the reports, managing the reports, everything, then obviously, right, you will be paid high, and also you will learn a lot. Okay, hence it is important that you need to understand, apart from Power BI tool, right? These are the things you need to understand. This is for the source system database, is meant for transactional purpose. This is meant for analytics. If they do it in a single database itself, both analytics as well as the transactional, it literally slow down. So in the case of OLTP system, the source system, they don't keep huge volume of the data, which means they don't keep more than 1 year data here. Okay. The more the years data you store it in a single database, obviously the volume of the data will be very huge. If you work on a huge volume of the data, it will obviously slow down your performance. though we have different techniques came into picture, both in the hardware side as well as from the database side. Like, you can create partitioning, you can create index for the partition, everything, all the options, though it is available, but still we don't keep everything in a single place. So analytics, you have a separate database, and for transactions, separate database. In the case of analytics, you're also, you have something like, schemas will be there, but you have something like, HR. Okay, you have another schema called HR. This is for HR and payroll, right? So different schemas are called subject areas here. And logically, they would have, divided a single data warehouse database into multiple subject areas, which are nothing but schemas. And each schemas, they have their own set of fact table and the dimension tables. Now you got a big picture, okay, in the data warehouse, analytics, right, of how the infrastructure will be, how the architecture. This is the ETL, the reporting architecture. We can say ETL and reporting architecture, or BI architecture. They call it as a BI architecture, business intelligence architecture, BI architecture. So in that case, in the BI architecture, reporting architecture, you have the source system and you have data warehouse. And the data warehouse itself, you have some staging area, all the things. Okay. Apart from this is for a business purpose. Apart from they have something called staging area. In this database itself, there is a separate schema for staging area. Okay. Apart from these schemas or subject areas, you will have, another schema meant for staging area. So in that case, what we do is, so see here, all the data are getting loaded here only. How come the data will get pushed here? Whatever the data that are available here, you need to keep it here also, right? One second. Hello. So here, whatever the data, getting stored in this database needs to be moved to the data warehouse. In the case of data warehouse, unlike the OLTP system, here we store at least 5 to 6 years of data here. But here you will have maximum 1 year data, or maximum 1.5 year data you will be having it. Whereas here you will be having at least minimum 5 to 6 years. In the case of banking, they store many years of data here. Okay, so they need to push the data from here to here. Otherwise, how your data warehouse will have data in it, right? So whatever the data gets stored here, that one will needs to be pushed to this data warehouse in order to keep the data in your data warehouse in sync with the source system database. They schedule some ETL jobs. Okay, I will write it neatly. This one seems to be a little bit cluttered. I'll just write it neatly. I go to the one way this reporting canvas is helpful. So here I'll just explain this one first because this is very important. So this is your OLTP system. This is your OLTP system, and this is what your data warehouse. Okay, this is what your data warehouse. Maybe all the things are there in a SQL server or Oracle. That is a different thing. The data warehouse itself, they have something called staging area. You have something called staging area. So what they do is every day the data gets stored here. For example, your order table. Okay. So every day the data gets customers are raising order, via app. Okay. The order gets stored here. Whatever the orders that get stored here, you have some customer table also, right? Which customer raised which one, and then the customer and order, and you have something else like customer address details, and you have something a product table. Okay, likewise, different multiple tables are there. So what we do is, whenever any new record comes in here, that record will get pushed to your staging area. Staging area. Step one is, the application will write the data into your orders table and other tables. Whenever any new customer comes in or existing customer comes and when they order it, all the tables data will get pushed to your staging area as it is. Okay, so here you have something called loading. Only the loading will happen between your source system to data warehouse. The loading, only loading will happen. So the order table data will get loaded into a temporary table. The product table will get loaded here. In case any new product comes in, any new customer comes in, any new product comes in, and any new order, let's say a customer raise an order, and or if the existing order itself, they make some changes, if they cancel it, whatever they do it, whatever the data that are there here, it's simply copied here on a day-to-day basis. Daily load will be there. Okay, you have some daily load, weekly load. Okay, and they load the data here in the staging area. It's a like duplicate of your source system tables. And then what they do is they they here in the staging area, they do the data transformation or data pre-processing. Use a simple term called T, transformation. So ETL, you need to aware of this one. E is extraction, or we can say instead of loading, right, we can say extract. Extract is nothing but simply extract that, read the data and load it here. Once you load it here, this is where we do the data transformation or data, the T part. The T part comes into your staging area. The first step is ETL, and second step is T transformation, and third step is loading, right? So here itself, they'll be load. Yeah, where it is going to happen, the loading again. The loading is gap, happening between staging and, the other data warehouse related tables. Okay, here only your loading will be there. So you clean the data and then you load it here. It is something like, you go to a market, buy all the vegetables and take it to your kitchen. The staging is kind of your kitchen. This is where what you do, you join the tables and you do the cleaning, everything. You do aggregation. In case of any duplicate records, you remove it. Everything you do it here. Once, like in kitchen, we do, cleaning of vegetables and, cutting and shaping the vegetables. And then we mix the ingredients, everything. Once you clean it and once you mix the ingredient, you simply load it here. The same way here, you join the tables. As part of data transformation, you filter the data, you join the tables, multiple tables, and then you do aggregation. And then what you do is you apply some business logic while transforming the data. Everything you do it in the temporary area called staging. And then once you clean the data, once you pre-process the data, and then you load it into the respective subject areas. Okay, subject areas. Now you got a big picture, right? So the ETL stands for extract the data from your source system as it is. Why are we not doing the data transformation here itself? While extracting the data from this table, can't I do the data transformation? Can I join the tables here itself and then load it here? No, it is not acceptable. Simply, the reason is they don't want this database to be disturbed by the other databases internally. This one has to be isolated completely. They will give only the read-only access. You need to find out which tables that are required for you to do the to create the reports, the reporting requirements given by your internal managers to to create those reports. What are the tables that are required? What are the columns that are required? You need to find out, and then you need to simply load it here. Duplicate, you can do it here. Okay, you'll be doing it here. So this is your in this one maybe right on approximately 1 year, approximately 1 year, data will be there here. Here, in the case of data, depends on the industry. For example, in the case of e-commerce, let's 5 years data will be there. Okay, or e-commerce or in-store, right? Maybe 5 years or 10 years, again, depends on the customers. But here itself, you will have petabytes and above volume of data. The volume of data is very, very huge nowadays. The volume of data, that is another biggest challenge. Okay, fine. So now you simply read that table. Any new data comes in, you need to identify which transactions are happening today that you need to load it here. That is called incremental loading. Okay. And load it here. And even the staging area also temporary. Okay. Maybe every once in 6 months, they will clean the data, remove, truncate the data and then load it here. Okay. And a lot of strategies are there. Okay. And that we'll discuss it later. Okay. Assume that at this moment the staging area will have only 6 months data in it, whereas here you will have maximum 6 months. Okay, here 1 year data. This one will be 5 years, or in the case of bank, 20 years data or 50 years data also they have it here. Okay, in this case, you simply read the data and load it here, and then you do the data transformation, everything, you join the table aggregation, everything based on the, let's say you create some additional columns, because the existing columns are not helpful for you to create the report. The classic example, net revenue, net profit, net margin, all the columns, right? These columns are not available in the order table and all. You need to derive some logic, and then based on some business logic, you need to derive the new column with the help of the existing columns. Likewise, you do all kind of cleaning, data pre-processing, everything, and then finally, once the data is readily consumable format, you will load it into your data warehouse with the respective subject area. For example, sales subject area, you load it here. And then in the reporting users, in the using Power BI, right, you will create the reports or dashboards. Here, just extract the data. Why they are not doing the transformation here itself? While extracting the data as well, they can join the table. They do. The reason is, if you do everything here, it will literally slow down the source system database performance, because people are accessing this database 24/7/365 nowadays. The business are open by 24/7/365 across the zones, across the time zones. The customers are accessing the database, everything. So in that case, this database should be up and running. Okay, database is up and running, but is that slow or is that pretty fast? As and when you select the products when you check out it should be pretty fast. If it takes delay, customer will lose their patience. Obviously, they walk out of your business. Hence, this database should be pretty fast, but just because with the interest of doing the analytics, if you squeeze this database by running joining the tables, and if you do any the data transformation while extracting data itself, it literally slow down your source system database. Hence, simply copy paste it here, and here do all kind of cleaning, everything here. It is something like in the vegetable shop itself. If you start cutting the vegetables, cleaning everything, if you do it, will they allow you? No, right? They will say, madam, many customers or guys, sir, many customers are there. If they come and do everything in my shop, I don't have space. They will find, bottleneck, right? They will say, take it to your home, something like that. Take everything and all the tables you replicate it here, and then data you replicate it, and then you replicate it, and simply you copy the table data from here to here. That's all. Once you are done with it, you join the tables. You know what is joining, merge, left join, right join, all the things you do it. And then what you do is apply some business logic, create some additional column, anything if it is required, and then you load it into your database. So here, in the case of staging, right, is also a database in most of the cases. This is where we do the data transformation. They will ask you, where is the staging area? Can you tell me your architecture? You can tell them. So we have source system, and then we have source system. In the source system, we have OLTP database are running. And in the data warehouse, we have a dedicated data warehouse. They did all the data modeling there already. Then they have, majority of the schemas, we could see that they used a star schema. What is star schema? The fact tables are surrounded by dimension tables. Okay, so in that case of good, you have the schema already ready. So in that case, you can simply import those tables and make sure that whether the relationships are getting created automatically. If it is not getting it, you can create it manually also. You have an option, right? Power BI automatically detects the relationship between the tables, provided that the common columns between the tables should be same. The common column name should be same between the tables. In that case, it creates the relationship automatically. That we will see it now. Okay. So here, what we are doing is in the case of Power BI, the data warehouse is there. You have a luxury already. They create the data model, design everything, fact table, star schema, right? Everything they create dimension table. Simply you import all the tables that are required to create the report that you need to do. You need to create it, right? That's all. Once you create a report, publish it on cloud, and there you create the dashboard, everything, and share it with users. So end of the day, you need to understand what is ETL. Okay. And the ETL also, they will ask you how frequently have you involved in ETL, extraction transformation. Yes, we have involved in. So what kind of tool that you used it? You can tell them for extracting the data, they are using SSIS. SSIS, I'll teach you very simple concepts, all one-to-one load. You can tell them between the source system to staging, majority of the loading task was, one-to-one. Let's say I have a customer table. I load the customer table to the customer table in the staging area. It's all one-to-one load. Majority of them are one-to-one. But there are some cases, right? It's a majority of them, right? Majority of them one-to-one. Once you load the data here, then joining everything, you can use SSIS. It's also a drag and drop. But again, in this case, even SSIS, you can do merging, joining, merging, right? You can do join, the left outer join, right outer join, everything you can do it. Data cleaning, everything can do it. Data transfer also can do it. And then you load it. You can tell them partially we used SSIS. In some cases, we used stored procedure to do the data transformation. Okay. And then but the clean the data, processed data will get loaded in the subject data or subject area in the report. Okay, in that case, what did okay, since you have involved in ETL, you tell me how frequently you extracted data on a daily basis. Yes, daily loads. We have daily loads close to 300, 360 daily loads were happening. And again, if you see Walmart, all the the giants, right, thousands and thousands of jobs are running on a daily basis. 360 daily, and a weekly also almost 300 ETL jobs are running, and monthly load, and daily load. Daily load is like you can say 460 also. Daily table lists, it's all happening on a daily basis. It's all automated automatically. But only our role is the staging area. We need to join the tables. And currently, I'm working in the maintenance and support project, maintenance and enhancement support project. In the case of maintenance, support, and enhancement project, your job is simply take the existing report, and they may want you to add some additional columns in the report, or some additional features, additional slices they want you to include it. Already they would have created reports, everything. It's all running. Okay. You need to do it. That's all. But if you tell them that you are working in a maintenance and support and enhancement project, you can easily tell that, in the current project, you are working for the last 2.5 years or 2 years. If you say it is a development project, then they will ask more questions. So you are saying that you worked in a sales subject area. How many reports you created? How many of them were complex? How many of them were, low complex, medium complex? Okay. And if you say, I worked on maximum 12 reports and for, 3 dashboards, how long it took? Maximum 3 months. You can say, right? And then they'll say afterwards, what did you do? Then how come, you put only 2 projects in your resume? Better you can tell them the current project is enhancement, maintenance, support project. It is ongoing project. In case of any load fails, in case of any additional changes needs to be incorporated in the existing reports, we used to do that for the last 2 to 2.5 years. We have been doing it. Apart from this, there are some cases they ask us to create some new reports from the ground up. Okay, but the data and table, everything were available. But still, for a specific subject area like a sales subject area, the day when I joined in this project, that's when they started doing the data model design. It was in the very nascent stage, and it was a very good experience for us to be part of that data modeling design team. I was able to gain a lot of insight, and even I contributed in terms of suggesting them to implement the data model in such a way to improve the performance. Okay, I suggested create some partition, everything. That one I will explain it later. So if you know this much at this moment, this is more than sufficient. Okay, fine. Now we will jump into the data modeling part. But there are cases, let's say we are talking about big customers all the time. Let's say in the project where you work, the project size is not that big, mid-sized customer, okay, and they want you to do everything from the scratch. They cannot afford having a data warehouse. Or maybe they wanted to set up a data warehouse after a few months down the line, not now. In that case, they don't have the data model already available. So you need to create a data model, everything from the scratch. So in that case, already, they would have came up with the table name, everything. What you need to do, just go ahead, import all the tables. Here, what I did, I just get data, click on the file name or table name. In your case, the data is available in SQL Server, simply go ahead and import it here. So the dimension tables, let's you have something called product dimension table, category dimension table, calendar table, everything. City data. Okay, what I will do is I will just open another file. I'll show you from the scratch. So I just click on the, one second, let me just click on the get data and see what happens here. Yes, I want to load an Excel file. Let's say in our case, the Excel files. Here I just in this sheet, we have something called in the Excel file. We have a sheet name called NC sales. I'm going to select and load it. If you load any data from a sheet which is there in an Excel file, it will display this sheet name. See, I have selected sales fact Excel file, but in that I have a sheet by the name of NC sales is there. Hence, it creates the table with the name of NC sales. You need to make sure that you are renaming the table. Remember that in the case of analytics project, you will have a fact table and then dimension tables. Hence, the naming convention also need to follow it, and you just double click on it and then give something like sales fact. This is the naming convention. We follow it for the fact table. Some cases it is reverse, fact sales, something like that. Okay, sales fact. Okay, and you can expand it. We can see all the columns. There are some junk columns. It needs some kind of cleaning. You can remove this. That we will do it later. And I'll just go to the model view and then check. Yes, the sales fact table got loaded here. Good. The next thing is here itself, I'm going to load other tables. Dim customer.xls customer dimension table. So though the table name starts with a dim, in this case, look at sheet one, and here, I'm going to go to the transform data upfront because I need to promote the first column as the column header. And then I go here and then use first to answer as use first to answer as, and then dim customer. You have customer dimension. So you might be asking this one, why do you tell it's a customer dimension, but you mentioned a dim customer. In practice, we give the name something like this, but when we talk, right, we say customer dimension. Okay, this is customer dimension table. Okay, we are done the cleaning everything, and I just go back to the model view, apply changes. Now, if you see here, the customer dimension table got loaded, and then the link also got created automatically. How it was possible? Because in these two tables, the common column cust ID is existing, and the name of the column also same in both the tables. Suppose in this table, the customer ID, right? Instead of cust ID, the cust space ID, if you mention it, it will not create a link. Since these two column names are similar in both the tables, it creates the link automatically. Okay. So one-to-many relationship. This is your dimension table. And then if you keep the cursor on top of this line, both the tables you can find that the cust ID column got highlighted. So with that, you can understand the basis for the relationship between these two tables is customer ID. Very good. The next one is I just hit the get data icon here. I'm going to load location dimension. I'm going to hit OK. And here also sheet one. Let us check. Yeah, here also it requires some kind of cleaning. Better, I will keep the Power Query editor open so that we can save time. Okay, here itself we can make the changes to even. Can change the name here. Dim location dimension. Here use first row as header. I'm going to select this one. Location key and location name is available. And again, I just click on the home. Here itself, we can load the data. And here, dim product. Okay, here the column names are correct. And again, being in this place, I'll be loading another table called dim category. Here the column names are not there in the proper place. So one way it is good, transform data, use first row as it is. So now cat ID in category, will get moved here. Yes, good. So everything is in good shape and you need to rename it. This is your dim category dimension. Here you can see only the category dimension. So you can see that, please note that, all the dimension tables, you will have a primary key in it. This primary key, it should not have, this column should not have duplicate values. For example, C001, the same ID should not repeat here. It's a unique column, it is a primary key column, in the product dimension table. But in the case of fact table, there is no concept of primary key here. Okay, you will have only the foreign key, and then along with the foreign key, you have your or the composite key, right? The composite key will have it. The composite key is your the foreign key, and then the measures in it. Okay, we are done. So I just apply this one, close and apply.
According to JP Morgan, Indian IT industry is going to be
Look here, I have loaded all these tables. Now let us, drag this, and we'll keep it in, we'll keep it little neat so that we can identify later point in time which table linked with which one. I just move this here and there in the proper place. And for the sake of clarity, we'll keep all the dimension table just above the fact table. And then the product dimension, yes, we can have it, that one also here. Probably I will move it here. And then customer dimension, and then the product dimension. This is, can someone tell me, it is a star schema or snowflake schema? What is this one? What kind of model is this? Can you all please type it in the chat window? All your contribution is required. Is this a snowflake schema or star schema? What is star schema? Star schema, in the case of star schema, the fact table is surrounded by your dimension table. If you see here, all these dimension keys are, flowing down from, flowing from the dimension table, the fact table. Very good, Kamal. Kamal answered correctly. This is not a, the star schema. It is a snowflake schema. In this case, we can see an hierarchy here, right? The category dimension is not linked directly with your fact table. Ideally, these two table contents should be there in a single table, but these two, the single table. For example, ideally we should have had a single table by the name of product dimension. So what they did, they have decomposed this one. They separated this product dimension table in two different tables. They kept all the categories separately in a table and product into a separate table. Okay, hence it is called your snowflake schema. How do you convert the snowflake schema into a star schema? You need to do denormalization. What is that term? Denormalization. Snowflake to star schema. You need to do denormalization. That means you need to combine these tables in a single table. So currently, what you are seeing is your snowflake schema, because in this case you can see that the dimension tables got splitted. Single dimension table got split into more than one dimension table. You can see some kind of hierarchy. The dimension tables got splitted, based on some hierarchy. Okay, under category, each category, multiple products are there, right? So they did it like this. But you can tell them, since star schema is best in terms of performance, we did the denormalization. Okay, we recommended the customers to do the denormalization. Instead of having multiple tables, you can join it and put it in a single table. Okay, and the reason is, if you have to, for example, you want to find out the sales breakdown by category, the category table cannot filter this on the fact table directly. Sorry, this cannot filter this table directly, because there is no direct relationship exists between these tables. The relationship exists between only these two tables. If the category dimension has to filter this table then it has to navigate via your product dimension table, and then only it can filter the fact table. Okay, we have a nice case study. I will just explain you right after this topic. Okay, many to many. Okay, so here you need to navigate via this table to filter this table. Okay, it cannot directly filter it. Even if it wants to filter it, has to do the filtering via this one. So if you denormalize it by combining these two tables in a single table, okay, so see the to it is easier said than done, right? So you might be thinking, okay, combining is pretty simple. It is not that easier. You just imagine the product dimension table have 1 billion products are there, and you have close to 50,000 categories are there. Okay, so while combining these two tables, there you should not mess up. There should not be any Cartesian product. Nothing should. You need to. This one I will show you in a separate session how to do the denormalization. You can use an SQL query itself, do the denormalization. That I will show you later. Okay. And here, yes, this is the model. And you can see that, we have the dimension table surrounded by your fact table. And in this case, you can see one next to the dimension location, all the dimension tables next to that, right? You can find the one here. And between the dimension table to the fact table, you can see star here, right? In the sales fact side, table side, you can see star here. But here, as an exception, we can see the star here because each category can have multiple products, isn't it? You have something like electronics category. Electronics, you might be selling multiple products. Okay, electronics is a single category. Under that category, you'll be selling many products, right? So hence one-to-many relationship. This is called one-to-many, one-to-many, one-to-many. So here the one-to-many is existing between these two tables. Okay, fine. So far, so good. So here, you need to create the. So for example, you have something like product key is there. I just scroll down here. You have product ID, but here product ID is there. Supposing you have the product key is there here, and here product ID is there. In that case, it will not create the relationship. That is the reason why you need to manually check, even though the relationship get created automatically, you need to manually check here. For the sake of illustration, I just go here and I'm going to rename this column as product key. This is how they've given you the data. Now you need to create a relationship between these two tables. Obviously, the dimension table should have a relationship with the fact table, but there are cases the dimension table should have a relationship with other dimension table, but it should not be standalone table, right? At least, this table should get connected here. Even this table is not connected directly. At least this one, any one of these two tables, right, should get connected with this one directly. Otherwise, how will you filter this table's data, right? So, but here what happens, you have the product ID is there, your product key is there. Okay, even if you make a change in your Excel file, like, you rename the product ID in your Excel file in the product dimension table, this is an exercise for you all, okay? And then load it here. You will find, once you load the data from the Excel file, the product dimension table, and then sales fact table, you will not find the link got created automatically. Because according to Power BI, Power Pivot, it will think, there is no product IDs available. There is no common column exists between these two tables. According to us, we know very well, we know the domain, the product key is nothing but product ID. But it cannot understand it. It doesn't have that much intelligence. How do I create the relationship between these two tables? So you know very well the product key is nothing but product ID. You can either drag and drop it on top of this column. Make sure that you drag this product key and then drop it on top of this product ID column, not on the other column. Once you are done with it, you need to cross check by keeping the cursor on top of this line. You can see that product key and product ID got linked. Very good. Is there any other way that I can create the relationship between the tables? Yes, you can delete this relationship. The other way of creating the relationship between the table is manage the relationship. Click on this manage relationship icon, and here you can click on the new one. You want to create a new relationship. Here you will find the drop down here. Click on the drop down, and here you can select the product dimension table, and here you can select the sales fact table. And if you see here, the cost price and cost price, got highlighted. According to him, this is a common column. Okay, the key column should not be a price, right? It is not a numeric column. It can be numeric column. It should not be like a cost price. Okay, and it should be a key column, right? The relationship should exist between the two tables. You need to define a relationship between the two tables based on the key columns or ID, not using price or quantity and all. Okay, since these two columns are common, blindly it got selected automatically. That's why we can see the gray color here. It is wrongly selected the columns here. Make sure that you click on the product key. Now it got grayed out, and in this table you click on the product ID. So we know very well by looking at this also, we can make sure that yes, P001, P01, the IDs are same. In the real world scenario, you will have a lot of confusions like this. Here they put some column name for the the ID column. Here they put some column, but in the real world, they say key column only. Ideally, here also product key should be there. But here they mentioned product ID. And you know very well, by looking at this value, you can see that, okay, this is, and then once you select it, you get, you need to select it manually in the manage relationship dialog box, one to many. Okay, so one to many, fine. And the cross filter direction is a single. I'm going to hit OK now. Now we can see that the fourth relationship got created. I'm going to hit this close button. Look here, it got created automatically. This time I did not drag and drop it. This is another way of creating the relationship. This one will give more clarity when you create the relationship. In this case, what happened? The cost price and cost price were got these two columns got highlighted, right? But one way it is really good if you use the manage relationship. Here you can see the data also, the sample data. Okay, product ID P001. Okay. Sometimes what will happen, you will have in the dimension table, you will find product key. Along with that, you will find another column called product ID. The sales fact table, you will have the product key here. And here your product key and product ID will be there. Okay, and that part I will explain you later. That is called alternate key. That I will explain it later. Okay, at this moment, these are the two common columns. We know very well, by looking at the data also we can make sure that these two columns are same. Only the difference is the column name. Anyhow, it is okay. You can go and hit OK here. Here what I do is, even in the case of sales fact, I'm going to say, because I want you to be familiar with the real terms, okay? Product key. I will rename it as product key. The key columns will be there. Location key, product key, customer key, not ID and all. Okay, product key. You can give some proper naming convention in line with the industry standard. Okay. Whenever you make changes, you make sure that you hover the cursor on top of this line. When you hover the cursor, you can find the two columns got it, then it is good. Okay, very good. We are done. So now you understood how to create the relationship between two tables manually. When you are supposed to create the relationship explicitly between the tables, that also we discussed. Very good. The next one is, I just go here and then I'm going to create a visual. Let's say we will start with table. Table visual is really helpful in terms of doing the troubleshooting, everything. And here, if I go here and the location dimension, location name, I just drag and drop it from my location dimension into this visual, and then the sales amount. We want to see the sales breakdown by location name. In that case, these two columns are coming from two different tables. I'm going to click on the format your visual. I'm going to say font. The font size, I'm going to increase it so that it will be visible. There is some blank values there here. Why are we getting some blank values? I just go here and then here the location dimension, BLR, CHN, everything is there. And actually it's a Mumbai, right? It's Mum and Bombay is there. Okay, see, this kind of issues you may encounter. There is some kind of inconsistencies that though the keys are not duplicating it, that doesn't mean your table is really good. Mumbai and Bombay, so in that case, what will happen is it will not throw any error because your location key is different. The Bombay for the Mumbai, right? The location key is different here and here. Simply accept. Just because it simply allow you to load this kind of data, that doesn't mean your data is perfect. So what will happen is, let's say in Mumbai, you made 10,000 sales, and let's 50,000 sales. You put it in this naming convention location key. Remaining for 50,000 transaction, it will get it will get distributed to this location key. And finally, it will confuse you. It will make you to think Mumbai, we are not selling well. Just give me a second. Recording. So you need to address these kind of issues that we'll discuss it later. Okay, so now we need to find out why the blank value is showing there. And I just go to the sales fact table in the location key column. I'll just check, do we have any duplicates, any missing values are there? Here we can see that only Mumbai. We don't see any Bombay related record here. Okay. Bangalore, Chennai, Delhi, Mumbai is there. BOM is not there, right? We don't see any BOM. I just go here and location dimension. Here, we don't see any bomb related data there, right? One way it is good. I just go to the Power Query editor. But there is a single transaction we can see that is happening in a blank record. Let us go and check why it is showing blank here. Here also there is nothing is there. And what I'll do is I'll just go to the location dimension table. But anyhow, here the bomb is there, right? Yeah. In the transform, not the transform, and here I just go and check manage reduce rows, remove rows, remove bottom rows. I don't need this one. Better I will remove it. How many number of rows from the bottom you want to remove? Only one. Now I just close and apply it. Let us do one thing. We will refresh it. Whenever you delete any record or when you add any new column, when you reload it, better you can refresh it. But it still shows 605. Let us go here and show as a table. And why the 605 is coming here. The relationship somewhere the key is not matching the BLR and okay, let me just go here in sales fact. I just go and check because based on the location key only we join those two things. 660 605.60, but it's okay, let me do one thing. I will just go here, sum of sales amount, don't summarize. Yes, we have something called 605 transaction is there. Okay, with that we can catch hold of it. I just go here, sum here, and then I just go to the model, and then let me see any sales amount that comes with 605. Yeah, this is the one. I just unselected 605.6. Only that record I selected and I hit OK. Look here, the location key was given wrong here. What I suspected was correct. Whatever the location key values that are there in your location dimension table, the same location key should be there here. Right? There is an issue here. Okay. And now we select all the data. And then I'm going to hit OK. This is how you need to troubleshoot, guys, in the real world scenario. And you need to go here. So see, the everything is good. There are no errors. There is no obvious errors. But when you put it here, it shows something nonsense, right? Okay, now how am I going to fix it? So I just where is my I think I closed it mistakenly. I just go here and transform data. I'll show you once again. Please concentrate. Look here. I'm going to click on the. Sorry, I opened another file mistakenly. See, we are in different report file. Okay. Oh my God. How come I came here? No, not here. It's correct only. Where is the table that I created? I'm just wondering. Yeah, this is where the new report, right? Correct. New report. And you open it, transform data. And then you go to the dim location. Can you see anything LLR here in the key? Nothing, right? BLR is there. Instead of BLR, LLR key went there. Because of which it causes some kind of confusion. Because whatever the location key that you have it, the same key column should see same key value should be there in your fact table in the location key column, right here. Here we have LLR column is there. I'm going to replace the LLR by BLR. Because of which it shows blank values, because there is no matching values for LLR in the location dimension table. Hence it got isolated. Now I just simply apply it. I don't close it because if any confusion comes, you don't have to waste time in opening this. I just go back to my report canvas. Look here, the blank record went off. Now you understood with this, why, what could be the chances for the blank values. In the location name, it was showing the blank value and it was showing 605. Actually, that 605 amount should have been absorbed as part of your Bangalore transaction. Okay. Because the key issue, it was not, capturing it correctly. Now we address that issue. Very good. So this is what we can see it now. Now we created the relation. Everything is fine. Now let us move ahead and explore something called bidirectional cross filtering. So, okay, in this case, what happened? The location dimension table filtering my fact table. So location name came from location dimension. The sales amount came from sales fact table. The location dimension table filtered this table. Okay, fine, very good. Next one is there is a reporting requirement. They want you to create another table visual wherein they wanted to see the sales breakdown by category. If it is a product, if the sales somebody is asking you, hey, give me the sales breakdown by product, then it is straightforward. But they're asking there is a new requirement wherein they want you to use the category dimension table to filter the fact table. How can I do that? It is not possible. For example, if I go here and when I click on the table visual, when I sorry, the category dimension. If I drag and drop category, it will come here. But if I drop the sales amount, it cannot do the filtering because these two tables, oh, it is doing good. Okay, let me do one thing. It is doing good. So now there is no direct relationship exists between these tables. Since there exists a relationship, right? It is doing it automatically. And that's what I was wondering here. The beverage is 400. Dairy is it did they do anything in the latest version? We imported everything from the scratch, isn't it? I was not using the existing report file. Very good. Okay, I just go back here and then so usually fine. So because we have the relationship, right? There is a relationship directly here. The category dimension is filtering the product dimension is filtering here. Okay, ideally, it should be other way around. Here, it is able to filter it correctly. Very good. One way it is doing it correctly. Okay, you have another requirement, reporting requirement. For example, they wanted to, in addition to these two table visual, they want you to create another table visual wherein they wanted to see each location, how many customers bought the products. Before that, I'm going to create another table visual. This is for our reference. Okay, I'm going to put the customer ID here and then the first name. So we know since the number of customers are less here, I just put it here. Instead of going to the data view every time to check the data, I just created the the view of the table here itself. So how many customers are there? In 7 customers are there. 3, 6, 7 customers are there. And location, you have this many number of locations. 2, 4, 6, 7 locations are there. Now the requirement is they want you to find out in each location in Bangalore and Chennai, each location, how many number of customers they purchase the products from you. So in that case, location dimension has to filter the customer dimension table. Do we have any relationships between any direct or indirect relation? Nothing, right? At least here, it has a, it got linked with this table, indirectly via this table. But here, there is no relationship exists between the dimension tables. This is a common design practice, right? You don't have to create the relation between the dimension tables. Usually, we don't create the relation between the dimension tables. But in this case, in the case of Snowflake, yes, we created the relationship between the dimension tables. Fine. But this is a requirement now. How do you use the location dimension to filter this table? So in this case, the location dimension table can filter the sales fact table because the location key is flowing from my location dimension to sales fact table. Whereas here the customer dimension table can filter this table. So these two tables can filter only this table. But this table cannot filter this table. Is there any other way this table can filter this table? Only way out is you need to, if this table wants to filter this table, on this side of the table, right, you need to double click on it and you need to enable the cross filter direction as both. So before I show you there, I just go back here in this visual. I just put the location name. I just drag and drop the location name here. And the next one is the customer ID. I'll put it here. You might be wondering why customer ID. Here the requirement is each location, how many number of customers they bought. Here, what I do is in the column section, the customer ID next to that, I click on the drop down. I'm going to use count. Count is number of occurrences. Okay, how many number of customers they bought product in each city. But here, unfortunately, it shows 7 because the location dimension table and customer dimension were not linked directly. If this table has to filter the customer dimension table, the only way out is you need to click on this table, the link, double click on it and change the cross filter direction both. I just hit OK. And then I just go back to my report and see what is happening. And then I will come back here and explain you what is happening behind the scene. And you wait for some time. Very good. It did a fantastic job. In Bangalore, it counted how many number of customers they bought. In Chennai, how many number of customers they bought. Delhi, Mumbai, Hyderabad, Pune, 4 customers in Pune. Mumbai, 6. So here, what is happening in this case? I just go back to the model view. Here, I enable the two-way communication. It's something like a two-way communication. This table can filter this table can filter only this table previously. Now this table can also filter this table. In this case, what happens is, literally speaking, it's something like, in your home, you have a tap, right? You have a pipe connection, right? You have some, the water should flow here. And then if the water happens to go back here, this guy can also get water, right? So listen, if this guy wants to, if this guy wants to, let's say if this guy wants to, get the water from this guy, he has to flow the thing back here. Maybe this is not the correct example. Okay. So what I will do is, it's something, let's take another analogy. Okay. This guy can speak to this guy and this guy can speak to this guy, but this guy cannot speak to these two guys. This guy cannot speak back to these two guys. So let's this guy wants to know this guy's contact number, and but this guy cannot talk to this guy, and this guy also cannot talk to this guy. One way is, okay, this guy can talk to this guy. If this guy is allowed to talk to this guy, then the communication can flow ear to ear, right? He can ask this guy, and this guy, since he can talk to this guy, he can get the contact number. Via this guy, he can access this guy, right, to get the contact number or to speak to this guy. So the when you see here, by default, when you create a relationship, one-to-many relationship, right, the location dimension fact table, the arrow is pointing down. Okay, the arrow is pointing down here. If the arrow has to go in the upward direction, right? So you can see that this arrow, I'm talking about this upward direction. In that case, if you find this, in the case of cross filter direction, both, if you set it explicitly, this table can in turn filter this table. Previously, only these two dimension table can filter this one. And is there any possibility this table can filter it? Yes, that is possible with only by enabling only the cross filter directions both. Yes, we enabled it. Now we can see the these the arrow, downward and upward arrow. So what happens is, now location can filter this one. This can filter this one. Hence, you can get this. You can filter this table via this table, like how the category dimension can filter this table via this table, right? The same way. So you need to explicitly set this one to cross filter direction both. They will ask you in the interview, what are the options that are available in cross filter direction? You can say single and both. What kind of scenario you can enable both? In practice, the both is not the recommended approach. That is not a best practice. But the reason why we wanted to enable the cross filter direction both is bidirectional relationship. Okay. If you want a specific dimension table to filter another dimension table, usually we don't have the direct relationship exists between the tables, the dimension tables. In that kind of situation, whatever we do is, right, the target table which you wanted to filter it. This is the source dimension of target dimension, right? Between the target and the sales fact table, you enable the bidirectional relationship. Supposing the customer dimension want to filter this table, then the target is this one. The target table and the sales fact table, you enable the bidirectional relationship. So, this requirement has been satisfied now with this option, with the cross filter direction. Now we can, so we have another requirement. We have another requirement. I just move this somewhere here. We have another requirement. I'm going to click on this table visual. And here, I just, so now this time I'm going to put the first name, the customer name. Each customer, how many locations they bought it. So instead of location name, I just drop the location key. I'm going to click on the drop down here. I'm going to enable count. Here also it shows 77. Yes, everything is same, correct. The number of customers here, how many? 6, 7 customers. Here also we have 7 customers. But the customer dimension table was unable to filter the location dimension table. In this case, this is the source and target. You are between the target table and your fact table, you need to enable the bidirectional relationship. You just double click on it. Go to the cross filter section, click on the drop down, select both and hit OK. Now it became bidirectional. Can you see downward arrow, upward arrow, right? I just click on OK here. Now we can see that Chris bought it in 7 locations. Hemal bought it in 6 locations. John bought it in 5 locations. See, one student, he asked this question. Okay, for example, the customer dimension table wants to filter this table. Why? Each customer purchased the product from how many locations? The customer need not to buy from the same location, isn't it? So you wanted to analyze in the past 6-month transaction, each customer purchased in how many number of locations in our shop. So in that case, this table needs to filter this one. Okay, we enable the bidirectional, it is happening good. Now the question is, the customer ID and location key, both of them are available here. If you look here, the customer ID is available. Why can't I? The location key is available here. Why can't I put the location key from here instead of the location key here? If you put it here, what will happen? Your customer dimension can filter the sales fact table. If you put the location key here, and then I'm going to click on the drop down here. I'm going to click on count. This gives you difference. So this column comes from sales fact table. This column came from your location dimension table. This column came from your customer dimension table. Let's say you have another requirement, something like this. You have another requirement wherein each customer purchased in how many number of locations, and in total, how many number of orders they raised it, how many transactions happened. So what is the customer ID for Chris here? You can find it here, Chris C002. To validate this, I just go back to data view. And then I select the customer sales fact. The C002 is Chris, isn't it? I'm going to unselect everything. Select C002. How many number of records are there? 25 records are there, right? You see here, look here at the bottom, you can see 25 filtered rows are there. The total number of records are 92. Out of the 92 records, 25 records are there, or which means 25 records are there for whom? C002. C002 is whom? That is nothing but Chris. Look here, Chris 25 transactions being made. Next, we'll verify Hemal. What is the key for Hemal? C005. I just go to the data view. I just go back here. and I'm going to unselect C005. This email, I just hit OK. How many 22 records are there for him? Yes. So this column is helpful to check how many number of transactions happened. How many transactions made by Hemal in our shop. How many number of transactions each customer made is different from how many number of locations they bought it, isn't it? These two are two different things. But when you use the customer dimension table to filter this one, it did a correct job, right? It filters this table to help us to understand how many transactions happened. And when you use count on this column in this table, the same location key column in your dimension table, location dimension table, when you use the count, it gives me how many number of times this person name is occurring in this 25 transaction. Chris, sorry, 7 times, right? So now, this one you have to watch my video if you are completely new one to this. If you cannot understand, you have to watch it, practice it. I will share this report file right after the session. You need to practice it, don't postpone. Very good. So now you understood how to enable bi-directional relationship between the tables. So one-to-many relationship and bi-directional relationship. Now the question is this a best practice? Going here and then enabling the cross filter direction both, it is not the best practice. Manually you configure it. In that case, what will happen? You assume that in the case of bank, 25 million customers are there. And then you do business, Citibank, you take Citibank, it's a global bank. Across the globe, they have, banks. You have millions of records, you have millions of records. Here you have, billions of records are there. And if you enable bi-direction relationship, it will literally slow down the performance. Just because this one visual, right, to satisfy, these two table visual, if you enable bi-direction relationship, what will happen? The entire report will get slowed down. For not, see, you're in the real world scenario, you're not going to work with only one page. You will create page 2, page 3, 10 pages will be there. There you'll be using different visuals or different columns and all, because you are using multiple tables, different requirements. And just because these two tables, if you enable cross filter direction forever, it will literally slow down the entire report, all the report pages. It will literally slow down the performance. Is there any way I can enable the cross filter direction only for these two visuals? Yes, that is possible using DAX. You have a DAX function called cross filter. So what I am going to do is I'm going to create a DAX function. Measure. How do I create a measure? Click on the modeling ribbon and hit the new measure. Here I'm going to say the total number of customers is equivalent to calculate count of first ID from your customer dimension table, comma, you have something called cross filter. So once you type the cross filter, you don't have to type the entire function name. Cross filter is also DAX function. Everything is DAX function. Calculate, count, cross filter, everything. The moment when you select it, you will find the syntax: left column name, right column name, cross filter type. In this case, the customer dimension table, customer ID. Sorry, not the customer ID. Here, 1 second. This is location. Yeah, the target column you need to correct. So the customer ID. The target column is customer ID, comma. In the case of sales fact, customer ID. Comma both. Here you need to specify third parameter called both. Both. Look here, it is already available. You just press the down arrow or just simply type it here, both. Or click on this one. This is the, you need to specify 3 parameters. One and second column, and the third one is the third parameter. This is both. If you specify single here, it's a unidirection. Okay, fine. So now count of this one, I'm going to click on the tick mark and see if we get any error. So already it is showing some error because I mistakenly clicked something. Look here, now the error went off. This is the one I just selected, right click on it, copy it. This is for your sake, I will just copy it. Control C, and then I'm going to close it. In the same table, I'm going to drop the new measure which I created. What is the new measure name? Total number of customers. I just drag and drop it here. How do you find out the column name? How do you distinguish the column name and the measure? Next to the measure name, you can find the calculator icon. With that, you can easily find out it's a measure. It is not a column name. Okay, fine. Now, with the help of this measure, the total number of customers measure, with this function, we are able to achieve the cross filter direction both. So what is happening here is, we want to use the location dimension table to filter the customer dimension table. Since these two tables do not have the direct relationship, we need to enable the bidirectional relationship between the target customer dimension table and then fact table. And both, this both tells us bidirectional relationship. Got it? This is the syntax here. Okay, which table you wanted to link it and what relationship or what kind of filtering needs to be done. Both. Look here what happened. This measure I just dragged and dropped it. Now we are achieving the same result here. Now I go back here in the location. Okay, here the customer dimension. This is the target table. This is the one I created the explicitly I configured as both. Here I'm going to say single. I'm going to hit OK. It is something like the simple analysis. You have your ICICI Bank mobile app. Okay. Whenever you want to make online transaction, you go and enable the online transaction, right? You have an option to check off that, right? You can check that one. And if you think, right, somebody is recurrently deducting the money from your credit card, you go to the app and then you can say that online transaction off. You can off it. You can switch off, right? So in that case, if any transaction happens unknowingly in the online, it will not get deducted. When on a need basis, you go and enable that option, you go and disable that option. So somewhat similar to this one here. For this visual only, you enable the cross filter direction both. Look here, now I remove the cross filter direction between these two tables, right? Can you see the double arrow here? No, right? I disable this one. How did I do this? I just double click on it and then I just made it single. Very good. Now I can see this column is no longer required. I'm going to say goodbye. I'm going to remove this. I wanted to understand both the manual as well as the programmatically how we can enable the bidirectional relationship. How did I enable the bidirectional programmatically using the calculate function? You have a cross filter function. Using the cross filter function, you can specify the tables that you wanted to enable bidirectional relationship by specifying these 3 parameters. You cannot use the cross filter version directly. You need to call this function via calculate function. One way it is good. In the case of calculate function, first argument is your expression. Instead of using sum or average, I'm going to use an aggregation function called count. Count will tell me how many number of customers are there in each location. In this case, you wanted to know how many number of customers are there in each location. Count will give me the frequency distribution. How many number of time the customers are there in Bangalore. How many customers are there in Bangalore? And it gives me that one. Smartly, we have programmatically enabled the bidirectional relationship between these two tables. So now the exercise for you is without fail. Okay, don't give me any excuse. You do the same thing, between these two tables. So use the customer dimension table and filter this table, and then you give me this. So or this output. Okay, you need to eliminate this column. Okay, and then instead you can create a measure like the way how I created it, wherein in the cross filter you need to use the product key. You need to use the product key column location key column, right? You need to use the location key column location key column in the cross filter function, comma both. In the location key dimension tables location key and sales fact table location key, comma both. In the calculate first argument for the calculate function is count of location key, not the customer key. So in that case, you will, and once you create the measure, you need to drag and drop it here. And then you check, the measure is producing the same output as this one. And then what you do is go back here and remove this bidirectional relationship. You need to, reset it to single. Okay, like how I did it. That is what the exercise you need to do it. Now another question is here. Let's I wanted to know, there is a requirement. How many number of products we sold in each category? Okay, you need to create a visual. This is another assignment. You need to create a visual. For example, I will go to the second page and create a table visual. I wanted to know in each category how many number of products. So I think we have direct relationship. Yeah, we can do that way. That is pretty simple. Anyhow, I will show you that one also. Let me just go here in the category name. In each category, how many number of products we sold. Yeah, in this case, where you need to bring in the data, not from the product dimension table, right? In each category, how many number of products are there? You can get it from here. Yes. And here I product key, I just click on it. I'm using count. It will give me the correct answer because we have the direct relationship exists between these two dimension tables. Fine. In beverages, how many number of transactions we made, how many number of invoices we built. For that, you need to go to sales fact table. For example, you can drag and drop the product key, and then you can go here and click on this one and click on the count here. Yes, here itself it gives you everything because we have the relationship already exists. In beverages, we have in this category, we have two products are there. Right, for these two products, we made 3 transactions, 3 invoices we raised. Here 1 and 7 is there. In frozen goods, we have only one item is there, but we raised the invoice seven times for this product. Okay, I have given you this one here. Personal care, 5 products are there. These 5 products, we sold it. We let's say 18 in a transaction. We sold this personal care related products. This also I did it. Okay, good. So in that case, this is fine. And okay, now I'm going to create another table. How much sales we made in each category. Category, I just drop it here, and then the sales amount. It is doing the filtering. This one we already did it, right? Correct. So in today's session, we discussed about how to implement the model design, how to do the data model design manually, how we can create the relationship between the tables. And also we have explored what is one-to-many relationship and what is cross-filter direction. And how do we enable the cross-filter direction, which is nothing but the bi-direction relationship programmatically using cross-filter function we have explored. Okay, I intentionally put this tables. Okay, though this table is not linked directly, but still it is linked to this table via this table. Hence, it is doing the filtering. The category dimension is doing the sales spec table via this product dimension table. It is good. Supposing I wanted to see how many number of products we sold in each location. That is another assignment for you all. So in that case, let's say each location, how many number of products we sold. So in that case, what you need to do it? You need to use this table to filter this table. How many number of products we sold in each location. In that case, you need to enable this is your target table, right? This is your source table. We want to use this one to filter this one. In that case, this one will become your target. You need to enable the bidirectional relationship. And each location, how many category we have, how many categories we made sales. Okay, how do I find out this one? So in this case, if you enable the bidirectional relationship between this one, you just give it a try. Okay, I want you to use the location dimension table to filter the dimension category table. But in this case, this table is not connected directly here. Via this one is happening. In this case, do I need to enable the bidirectional relationship between product and sales fact, or do I need to enable the bidirectional relationship between the product dimension category table, in order for this one to filter this table? Give it a try. Okay. Each location, Bangalore, Chennai, Pune, in each location, I know how many categories, we made sales. We want to see that. Just give it a try. Okay. That is another assignment. Okay. Apart from this, we have active and inactive relationship. What we will do is, tomorrow I have some other commitment. Day after tomorrow, we will continue the same time. We will, so that I can compensate last week's sessions. Okay. In that session, we will see what is active relationship, inactive relationship. And also how do we enable the inactive relationship as active relationship programmatically. Plus, we will explore the many-to-many relationship. I thought of covering many-to-many relationship because today's session went interestingly, right? We did a lot of analytics. We did filtering, right, with the different thing. One way it is good. So day after tomorrow, I'm going to finish off the data modeling part. What you do is, in the meanwhile, please watch my previous batch videos for the active, how to enable the inactive relationship to active relationship. First of all, you need to understand what is active relationship, inactive relationship. And the next step is the inactive active relationship and how to we programmatically enable that. And also, you explore what is role playing dimension. And then the next concept is the many-to-many relationship. That's very important. Many-to-many relationship and different scenarios also we'll explore it. Okay, we'll finish out off the data modeling part by this Wednesday, so that the upcoming weekend we will be, we'll be in a better shape. Okay. Or, in case what we do is, right, in future, in case I cannot, this weekend I'm occupied. 1 second, I don't want to record this one.